Hey everyone, welcome to the Pre-algebra 8.1 video where we are talking all about relations and functions. Alright, real quick, before we get in there, we just need to make sure we're good with graphing points. So as a quick review, I gave you the point -2, 4, and I just want you to real quick think about what you think this guy is called and this guy is called, and then we'll move on. Alright, so hopefully you remember that that is our x coordinate. And that 4 would be our y coordinate, okay? And if we were to graph that, I would go, well, I have to start at the origin at 0, 0 and move left 2 and then up 4. So when it comes to the x-coordinate, negative means left, positive would mean right. When it comes to the y-coordinate, positive means up, negative would mean down. So left 2 and then up 4, and I would get that right there, and that would be -2, 4. All right, if you're not good with that, please watch that again, or go ahead and you want everybody to try this one. Why don't you graph 5, -4.5, and I'll just give you a sec to try that. And let's see, 5, -4.5. So the first coordinate is my x. So on my x-axis, I got to go to 5. And then I'm going to move down from there. How much? Well, I'm going to move down because it's -4.5. So 1, 2, 3, 4, and then 5 would be there. So I'm looking right there. All right, I'm sure you're good with that now. So let's move on. We're going to talk about some definitions. This is a big part of this video. All right, and so the first thing is relation. All right, so in algebra, we're going to talk about relations consistently. It's basically what we're going to do from here on out. Everything is a relation. And a relation, algebraically, is a pairing of numbers in one set or for one situation is another way to say it. So over here what I did is I gave us a table of values, which this whole thing is called the relation, okay? And it's data that's for one set or one situation. So this situation is about alligators, okay? And the age of alligators in years related to the length that they are in inches, which is represented by y. So we have an xy table, and this whole thing is called the relation. All right, domain is next. Okay, domain is all of the x values in a set. So my domain would be all of that right there, the 2, the 4, the 5, the 5, and the 7. All of that would be my domain. Let's see if I can get this orange color back. Oh, I probably can't. Well, that's all right. I'm going to get close. All right, so the domain is all the x values in a set. Okay. Similarly, an input is just one individual x value. So, whereas we circle the whole thing for the domain, an input would be just that, or just that, or just that, or that, or that. Okay. The range, okay, is all of the y values in a set. So here is our range. Okay. And then an output is one y value in a set. So whereas the range is the whole thing, and output would be one of those, or that, or that, or that, or that individually. Okay. And the last thing we'll talk about is a function, okay? So a function is a relation. So again, this thing is a relation right here, but it may not necessarily be a function. It might be, but it might not be. And the way you tell is with functions, you look at a relation and determine if that relation is also a function. You say, okay, does each input have only one output? Okay, and so let's talk about that for a sec. Let's go up here. Okay, does each input have only one output? So I have an input of 2. He is matched with a 32, all right? Input of 4 matched with an output of a 59. I have an input of 5 that's matched with a 65. I have another input of 5 that's matched with a 69. All right, and that right there is going to be the key. It looks like we have that these are two separate points, and they are, but this input and that input are the exact same. So if you were to make what's called a mapping diagram, you would do this. You'd have x, an x column, and a y column, okay? And we would go in order. All right, so our x's, we have a 2, we have a 4, then we have a 5 and another 5. But on a mapping diagram, you don't repeat, basically, the same number. So we have a 5, and then we have a 7. All right, and then I'm going to write what 2 goes with. Well, or well, actually, let's do it in order. Okay, so we'll do 32 next, and it's pretty much going to line up. Then we would have numerically in order 59, then we'd have a 65, we'd have a 69, and then a 96. Okay, and so then what you do is you match them. So 2 goes with 32, 4 goes with 59, 5 goes with 65, but he also goes with 69. And then the 7 goes to the 96. And here's the problem right there. You have an input of 5 that's matched with 2 different outputs. So this is a relation, but this here is actually not a function. Okay, so let's do another little exercise here. What I want you to do is I want you to represent this given relation, which is right here. So it's not in a table, it's a point format or coordinate format. So I want you to represent that with the graph. And basically when it means represent the relation, it means graph the points. So why don't you pause the video and give that a shot. All right, so if you graph the points, it should look like this. So go ahead and match it with mine, make sure it lines up. And then what we're going to do is I'm going to show you another way to test if a relation is a function. Again, they told us this is a relation, and it is because it's just a series of points, so it is a relation, but is it a function? So what you do is you perform what's called the vertical line test. And I'm going to take this vertical line, okay, and I'm going to, if I can, there we go, move him. What I'm going to do is I'm going to move this across my coordinate plane. And if that line passes through 2 points or more, 2 or more points at any single time, it is not a function. So as I'm moving it vertically, there, it passes through 1 point. But it's only passing through 1 point right there, so it's fine. So we keep on moving. It's still only passing through 1 point, keep on moving. And then right there, this vertical line actually passes through both of those points at the same time. And so what we would say then is this: it fails the VLT, or the vertical line test. Therefore, it's not a function. All right, so what I want you to do real quick is figure out if this relation that's represented is also a function, and play the video when you're done. All right, so what I'm going to do is I'm going to, because it's on a graph, I'm going to see if it will pass the vertical line test. So I'm going to draw my vertical line. I'm going to start moving it. Okay, it's passing through 1 point, another point, another point, another point. Okay, nothing, 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 another point. And then right there, that line is passing through multiple points at once. So therefore, it is not a function. But keep in mind, it is still a relation. It's just not a function. So same thing. This time I've just given you a mapping diagram. So why don't you determine if the relation is also a function? Okay, so remember, relations are functions if each input is only paired with one output, which that's saying the same thing as the vertical line test, right? Here we're figuring out, is each input only paired with one output? And here it wasn't, okay? The input of 2 was actually paired with the output of -4 and with the output of -7. Now, it's not as clear on a graph as it is on a mapping diagram, but they'll both give you the same thing. So if I look, this input of -2 is paired with 12. Same thing there, same thing there, same there, and same there. I don't have like -2 going to 14 as well as 12. That doesn't happen here. So actually, we would say that yes, indeed, it is a function. All right, so in case you weren't hungry, you're definitely not now. Pretty disgusting. So what are we talking about? We're going to talk about competitive eating, all right, which actually can be a fairly lucrative sport, believe it or not. So I did a little research here, and I came up with this table. And the table basically just lists some competitive eaters from around the world, the number of years they have been eating competitively, and then the amount of money they've earned in their sport. So we're going to do a few things. We're going to identify the domain, the range. We're going to draw a mapping diagram of this relation. We're going to graph the relation, and then we're going to determine, is it a function. So I'm actually just going to turn you loose on this. So why don't you pause the video, do what you can. I bet you can probably do it all correctly, and then play it, and then we'll kind of see how you did and keep on moving. All right, so first, for identifying the domain, remember the domain is all of the inputs or all of the x values. So your domain is right there, the years in sport. Okay, now identify the range. The range is going to be all the y values. Now, what if I had said identify an input? Well, an input would be one of those, or one of those, or one of those, or one of those. What if I said identify a range value? Well, you tell me one of those, or one of those, or one of those, or one of those. And if you look at this real quick, I don't know if you looked at these, but look. This guy right here, Joey Chestnut, has been in the sport for 15 years, and he's made $200,000 off of just eating. All right, so I suppose if you're good at it, you could probably make some good money at it. All right, so let's draw a mapping diagram of this relation. So remember, a mapping diagram is going to look like this. It's going to be, probably too much there, X, Y, okay? Or input, you could say, and output. And then we just kind of fill in. So we're going to do it in numerical order. All right, so we got a 10, a 9, a 15, and a 5. So we're going to do the 5 first, the 9, the 10, the 15. All right, now for the output or the Y column, again, numerical order, 15,000, 20,000, 130,000, and then lastly, 200,000. And then we just match, right? So the guy, Patrick Bertoletti, 10 years, $130,000. Eric Booker, 9 years, $20,000. And Joey Chestnut, 15 years, $200,000. And then Ed Jarvis, 5 years, $15,000. And there's your mapping diagram, okay? Now, what about graphing the relation? So we're going to need a graph for this, so hold on. All right, so here's the graph I came up with. And I'm actually only using one of the quadrants. You remember that a graph is made up of 4 quadrants, technically, if this is our x-axis and our y-axis. So that'd be quadrant 1, quadrant 2, quadrant 3, and quadrant 4. I'm only using this first quadrant right here because I don't have any negative values, right? You can't have a guy who's or a girl in the sport for a negative amount of years, and I suppose you could have someone who lost money, but generally these people, they just enter in the competition and they either win money or they don't win money, but they don't really ever get, lose anything. And so what I did is I figured, okay, well, on my x-axis, the lowest I have is 5, the highest is it's 15, and I have, a 9 and a 15, so multiples of 3, so I just went by multiples of 3. And then for my y-axis, I know the lowest winnings I'm going to have to graph is 15,000. The highest is 200,000. So I just decided to go by 20,000. So it's money in thousands. So 20,000, 40,000, 200,000, et cetera, et cetera. So to graph, first point would be 5 and then 15,000. So I got to go right to 5, which is going to be approximately right there, and then up to 15,000, which is going to be more or less right there. Okay, not super exact, but it's there. 9, 20,000, so over 9 up to 20,000. Then I've got to go over to 10 up to 130,000, so 10 is going to be approximately right there, and then 130,000 is going to be right about there. Okay, then lastly 15, 200,000 over to 15 up to 200,000. Okay, so there we go. We've done our mapping diagram. Okay, we also then graphed it here with, should have really done it in blue to keep everything color coordinated, but there's our graph. And now we see is the relation of functions. So again, we can go to the mapping diagram and figure that out. We can go to the graph and figure that out. Let's go to the mapping diagram. Okay, is every input paired with only one output? Well, yeah, 5 only goes with that. 9 only goes with 20,000, 10 only goes with 130,000, 15 only goes with 200,000. So yeah, we can tell from the mapping diagram it is a function. Now what about the graph? Well, remember when it comes to a graph, we do that vertical line test. So I'm going to kind of strike a vertical line here, and I'm just going to pass it through. And if it goes through more than one point at once, it is not a function. Okay, now I know our graph is kind of squished, but there it's only passing through one point. There it's still only passing through one point. There it's only passing through one point, and there it's only passing through one point. So either way you look at it, yes, it is a function. Okay, you could say yes, the relation is a function. And what does that mean? Well, we're going to get really more into that in the next couple of units, but what it means is that the earnings are a function of the years in the sport, okay? And so we can kind of look at that and look at the trend, right? So the guys who are in the sport for fewer years don't make as much money as the guys who are in there a little bit longer. They make a lot more. And we're going to get way more into that very soon. But that is all I have for you guys for right now. Thanks for sticking with it. Look forward to talking with you in class about functions and relations.